Okay, so I'll start off by sharing this flowchart, which will help you identify which of the 4 conic sections you have. This one will start off with this part right here. Are x squared and y squared both present in your equation? If the answer is no, if only one of them is squared, then you have a parabola. If both of them are squared, then you go down this way. Okay, now do x squared and y squared have the same signs? Okay, if they have different signs, that would be a no, then you have a hyperbola. If they have the same signs, that would be a yes, and you come down this way. Do x squared and y squared have the same coefficients? You know, the same number. So if the answer is no, you have an ellipse, and if the answer is yes, you have a circle. Okay, and I'll refer back to this flowchart later on as needed. Alright, so here we have equation in standard form. It's already factored and ready to graph. So first thing you have to do is identify the shape. Because we have the same sign, x squared and y squared are both positive, and they have the same coefficient, and then we know this is a circle. So the circle has a center at HK. Now this is H, this is K, so it's going to be 4, -3. And the radius is the square root of 9. Okay, because this here is r squared. So this gives me 3. Okay, so you go to the graph, 4, -3. That's the center. And I would just simply count 3 in units in the 4 directions, left, right, up, and down, and connect them as best as you can, forming a circle. So 1, 2, 3 here, here, and here. And then just connect the points. Okay, there's your circle. Okay, so this one, again, plus between the 2 terms here, between the x squared and y squared, so they're both positive. They have different coefficients because the denominators here are different. So this is an ellipse. The center is HK, so that would be +1 and -2. I get that from here, the H, and then the 2, the -2 here, the K. Now remember, with the ellipse, the orientation is determined by the biggest denominator. So right here, the biggest denominator is 16, and it's underneath the Y. So that means that our ellipse is going to be horizontal. It's going to go longer this way. Okay? So the A value is the square root of 16. And the minor axis, square root of 4. Okay? So let me draw the graph. Okay, so here I have the x and y. 1, -2, that would be the center right here. Then I'm going to go 4 across, 4 left, 4 right. So 1 plus 4 is 5, 2, 3, 4, 5 right here. And then 4 to the left, so that means I land on -3. And then from top and bottom I go up 2, down 2 from the center, so that would be right here and here. Okay, so those are the 4 dots, the outside ones that form the sides of the ellipse. Now it doesn't ask you to label the foci. If we wanted to label the foci, remember that's c squared equals a squared minus b squared. So that would be 16 minus 4, which is 12. And so you would take the square root of 12, which is 4 times 3, so that's 2 radical 3, and approximately, let me get my calculator, so it's 3.46 from the center. So 1, 2, 3, about here, and about here. Okay, and that's it. So the vertices are 2, 3, 4, 5, -3, -2, and 5, negative 2. The foci from the center, you would be, well, actually, they're not going to ask you for that, so let's not worry about that right now. Let me erase that part. Alright, so this one here, because there's a negative in between the x squared and the y squared, this one is a hyperbola. The center is hk, so that'd be negative 1, negative 2. Remember, we get those from here and here. Now with the hyperbola, it doesn't matter, the orientation is not determined by the biggest denominator. It's actually determined by the one that's positive. So right here, the x is positive, the y is negative, so we look at this one. Okay, this is your a squared. Okay, so we're not looking at the biggest number this time, we're looking at whichever one's positive. So this determines the orientation. So that means that this is going to be a horizontal hyperbola, so it's going to go like this. Okay, the a value is the square root of 4, which is 2. The b value is the square root of 9, which is 3. And the c value, remember c squared equals a squared plus b squared. So c squared is 4 plus 9, 13. So c is it's actually equal to the square root of 13. And approximately equal to 5.6. Okay, so the graph is set up. We have the center at negative 1, negative 2. And then from there, we're going to count 2 units left and 2 right. Those are going to be the vertices. So right here, and 1, 2 right here, right over the negative. And then 3 units up and 3 down from the center. So that would be here. 1, 2, 3 right here. Okay, and then we're gonna use those 4 dots to draw a rectangle. Those will become the sides, part of the sides of the rectangle. Remember, we're using dotted lines because this is just gonna help as a guide for you to graph the hyperbola. Okay? And then we're going to draw the 2 asymptotes. They're the diagonals of the rectangle. Okay, so it's going to go up 3 over 2. It's about here. And then on the board, or I would use a ruler. But right now on the iPad, it won't even show you. So I'm just using the graph to guide me, the grids, so that it's like that, and then like that. So those are the 2 asymptotes for this graph. The slope is 3 over 2 and negative 3 over 2. Again, we use these numbers right here for our slope. It's always the y over the x, so whatever number is underneath the y, and then over whatever number is underneath the x, the square root. So 3 over 2 in this case. So now we're ready to graph the function. So you go from the vertices, so in this case it's at 1, negative 2 right here, and just draw the curve. So draw that branch, and then draw the branch. And remember how we determined that it goes sideways and not up and down? Is because we look at the positive one. So the x is positive, so that means that it's going to be a sideways hyperbola. Okay, not an up and down hyperbola. That's how you determine. Okay, so we're going to be graphing this equation. First off, we have to identify the shape. Again, it has both x squared, y squared, so it's not a parabola. And they have the same sign, so it's not a hyperbola, the x squared and y squared. And they have different coefficients, so this is an ellipse. Okay, because the coefficients 4 and 1 are different. So now, this is where we do completing the square first, because we have to change it from general form to standard form. So put your x's together in standard form, so that's 8x. And then give yourself some space, y squared minus 6y, and then space, and then, sorry for the ad, and then this is 3. So before we do completing the square, you have to make sure that this coefficient is a 1. So I'm going to factor out a 4 for out of the x terms, okay, the ones that have x. So that gives you this, and then y squared minus 6y plus equals 3. So remember what you do, the two things you do to the b term. Okay, we take half of b and then square it. So half of b gives you 2 divided by, I'll just put it here on the side, 2 divided by 2, and then we square it. So that gives you 2 divided by 2, 1. 1 squared is 1, so we're going to add a 1 right here. Let me change the color. Okay. And then do the same thing with the negative 6. Negative 6 divided by 2, then we square that. So that's negative 3 squared, so that's 9. So we're going to add 9 right here. Okay. Now whatever you do on one side, you have to do on the other. Okay, so we added I physically wrote a 1, but I really added a 4 right here because it's 4 times 1. So I added a 4 right here, even though I physically wrote a 1, right? So I'm going to add 4, and then the 9. Okay, so now I'm going to factor. And then add on this side, so that gives me 16. Now for the equation to be in standard form, you need to have a 1 on the right side. So I'm going to divide everything by 16, every term by 16. So here I can reduce. Okay. Now remember for this one, for the ellipse, the orientation is determined, or the major axis is determined by the bigger denominator. So right here I have a 16 underneath the y, so that means that this one's going to be longer this way. Okay, vertical. The center is, let's see, move it up, HK. So I look at negative 1, positive 3. The A value is the square root of 16, which is 4, and the B value is the square root of 4, which is 2. And then we plot that. So here we have negative 1, 3. That would be the center. The A value is 4, so we're going to go 4 up. So that would give us 7. And then 4 down from the center. That would give us negative 1, negative 1, negative 1. And then sideways from the center is 2 units. So here's 2 units and 2 units. So use that to graph your ellipse. Okay, and there you have it.